Yard sale.
And plants too. And
Huh?
plants too.
And
Plants and yards. Plants.
And a yard sale.
plants and books.
Yeah.
All right.
Yeah. We probably finished books.
There's the bell. All right, I guess we can start.
Okay.
Close the door, but
All right. Hi, everybody. I'm Bob Feely. I'm the president of the Historical Society here, and welcome. And we have an interesting program for you tonight, and we hope you enjoy it. And I'm going to also invite you all Saturday night at 6 o'clock. We are starting our annual meeting. It's a potluck. If you didn't get an invitation, that's okay. You can come anyhow. And if you don't bring anything, that'll be okay too. It starts at 6 o'clock. We have a very short meeting. There's only a couple of things that we do on it. It shouldn't take more than 10 minutes for the meeting. And then we'll go into the program that we're going to have on Saturday night. So I'm going to let Betsy introduce our guest tonight that's going to be our speaker. Thank you all for coming.
thank you, Bob. Hi there, I'm Betsy Hamala, and I am the secretary of the, oh, it's being live streamed. I guess I should say yes, huh? Got it. Okay. Anyway, about 10 years ago, Peter came and did a program on DNA. I forget what the actual title was, but it was absolutely fascinating. And as it so happened, people, because of this, I don't know why, because of COVID or because of people being home and Ancestry, that program on TV that is so wildly loved by people. People have been asking me, well, are you going to do a program about DNA? I said, I know somebody who has done one before. And lo and behold, Peter came to our attic treasure sale. And I bumped into him. I said, would you like to do that program again? So he said, I would be happy to, but I'm going to do more research. So he's been researching for a couple of months and he's twisted it around a little bit, but he certainly knows a lot more about DNA than I ever did. So I'm happy to welcome everybody on Zoom. And hi there, Elaine and Paul. Hi, Cheryl, whoever is going to join us. So I welcome Peter Jefts. So you can do whatever you wish, and we're here.
Okay. Good. Right, I'm not just doing genealogy, although we're going to do genealogy later, but I want to sort of go really back to the very beginnings of life, because DNA is life. I mean, the coding for DNA is in all the plants, all the birds, all the creatures, big ones, little ones. The only one that really don't have a lot of it are viruses. And some people don't even consider them to be alive, because they're such parasites that they do have some DNA. And that's what they inject into us when we get sick. And then they get our cells to reproduce themselves, because they can't reproduce themselves, and that's how they spread around. So they are sort of on the very bottom, but anything above that is certainly, that includes dinosaurs. I mean, it includes everything, going right back to the very beginning of when life got started. And that's where I want to start, is when life got started. So the very beginnings, this was like 3 billion years ago. Life started as little chains of molecules, and eventually, after some time, formed into basically 2 different kinds of single cells, one of which becomes us, all animals, because we move around, and the other one were plants, because they're static. So one of the things that you do get into, go to one of the databases, one of the features that they'll offer you is they'll tell you what your mitochondrial DNA is. Mitochondrial DNA is not, it's part of us, but it's not a part of our 46 individual chromosomes, the chain of helix. It's not part of that. What mitochondrial DNA happened a very, very long time ago, when cells are single, and the cells are just moseying around, and somewhere along the line, one of them or more swallowed some bacteria, and the bacteria got incorporated into the cell. And the one that we captured, and again, our mitochondrial DNA is specific to us, but the idea is the same for all antigens. So what the mitochondrial DNA does is it was a little bacteria, and it does something which I learned in biology and just remembered it by chance, is that it produces ATP, which is an acronym for a certain chemical. ATP we use in our bodies to bring it down a level. We release the energy from ADP by turning it into ADP. And so that's what this mitochondrial stuff does. And it obviously was very useful to us because it allowed us to get another level of energy. And when I say us, I mean when we were single cells. So mitochondrial DNA is still important to us in terms of understanding who we are as a species. Mitochondrial DNA, when you do your swab or whatever it is that you do, what they do is they look at every cell in our body contains mitochondrial DNA, just like every cell contains the double helix. So, but this is only a very short string. It's only about 18,000 units. So it's not in genetics terms, it's not an awful lot. Because of the nature of it, because it's in all of our cells, we're not talking reproduction here, we're talking about our bodies and cells, is that the mitochondrial DNA that we inherit from our mothers, because the mitochondrial DNA is in the egg from which we are finally, an embryo, etc. So that we only get that from our mother because it's in the egg. When the sperm comes along and joins to fertilize it, it has mitochondria, but it's stripped away. So when you're doing genealogy, some of the sites will allow you to find out what your mitochondrial DNA is. And for me, I'm an H, so that means my sister's an H, my mother, my grandmother, going all the way back. And mitochondrial DNA, because it's inside of our cells and is not out in the world, it doesn't mutate very much. It's pretty much the same. The mitochondrial DNA that I have was from a grandmother who lived 35,000 years ago in what's now southern France. There are only for Europe, and I think most of us Europeans here, there are about 7 different mitochondrial DNA that Europeans share. So everyone has, there's different ones, and where your people came from. And a British biologist or genealogist, I think he's a biologist. He wrote a book some time ago when we first started getting work on mitochondrial DNA. He named all of the different ones. So mine's H, so my grandmother is known as Helen. So they have different ones. So this is basically, this woman who's my ancestor basically lived in the area where we have the caves with the rock, the cave paintings on them. So it's that far behind, and I mean, that's one of the things that I would like you to know is that there's that part of it. And it's very well documented because it's in our cells. The other, like men, our Y chromosomes mutate rather readily because they're small and they're subject to a lot of mutations. But this is a very static kind of thing. Along with that, just so I know, we're not talking about the 23 or the 46 that we have chromosomes. The other part that we've all heard about, we've all seen the commercials on television, were probiotics. So here we're talking about a similar thing, but instead of being embedded in our cells itself, we have trillions of bacteria that live in our guts. And it's a similar story because they came into us and they found a nice little place to live. And in return, they produce all sorts of things that we need. For instance, vitamin K. we produce our own vitamin K because of the bacteria that live in our gut. And of course, they also aid in our digestion and do an awful lot of other things having to do with autoimmune functions as well. And there's a lot of them. Approximately, somebody my size has about 5 pounds of bacteria. Now, that's a lot when you think about how little bacteria are.
Yeah.
So it's a very large piece of who we are. So as I was explaining before, this one of these books that I read is Assembly Required. And that's mainly the theme of this, is that we're not just, people think that we're just our genes, we're just those chromosomes. No, we're not. We have all these other things. And the stuff that lives in our gut just doesn't come from the air. Again, when we're born and we start to have milk from our moms, we inherit hers. So she populates our little tummies from the very beginning, and then those grow and change over time. They're very important. I've lost my own, almost all of mine a couple of times to antibiotics, and it's hard to get them to grow back. Okay, so that's where we're starting on that. Let me just check where I am. Okay. How we found out about mitochondrial DNA, I think, is very interesting. We knew that scientists knew that there were these little things in the cells, but they didn't really know what they were. And it wasn't until a scientist named Lynn Margolis, she had been working with these little pieces of bacteria. She'd see them in cells, and she was wondering what they were. And then finally, she came up with a theory, and she is the one who came up with this, and she had a hard time getting people to believe it. But she said that just what I said to you, we ingest these cells ingested. We took on these bacteria and got them to use it. She calls this symbiosis in evolution. In other words, this is a big deal. In other words, we always thought that evolution was involved with like small changes over bodies over a long period of time, like giraffes. But she said, no, we had an explosion here because all of a sudden we had these bacteria, which helped us. At the same time, the other part of the story is the plants did the same thing. They ingested algae, which allowed them to start to synthesize. Before they ingested this algae, they were just putting on single cells and just moving around, not doing too much. Her theory is endosymbiotic. That's her theory, endosymbiotic. So that's what she said. She didn't get an awful lot of recognition because she wasn't traditional. She was a very iconoclastic thinker. And just on a personal note, she was married to Carl Sagan. So the astronomer, popularizer. The DNA in our cells, aside from the mitochondrial, lives in the nucleus of the cell itself, and that's where our DNA resides. In our own cells, we have it. Now, of course, that's not the most important part. The most important part is when it splits into, and one half goes to your mother and half goes to your dad. And that's when the 26 split apart. Okay. That's for later.
This is Betsy. I'm kind of in charge here, but I'm not really in charge because I really don't know how to do this, but I'm learning.
So we all know how fast technology is.
Oh, geez, yes.
Today. So after they did this one comparison of mitochondrial DNA, that during the years after that, Pablo was able to sequence 55% of the Neanderthal genome, which gave us a whole lot of different things. He published his first primary publishing was in 2006, and in 2010 he published the paper showing the 55% that he had confirmed where it was Neanderthal. After that, the other thing that they're very clever when they come up with these things. when they were able to do that, they then compared the DNA from 5 different individuals from across the world. In other words, so they got very, very different people, very different. One European, one Middle Eastern, Asian, and a couple of Africans. So it's a very diverse, so, and when they looked at did the comparison, they discovered that the European, the Middle Eastern, and the Asian, for us, those humans from all had pieces of Neanderthal DNA. The 2 Africans did not. So they're very good at piecing together puzzles. So what's the story there? Well, we know that our species was one of the very latest hominids to leave Africa. And we left Africa approximately probably 125, 150,000 years ago. So relatively recent. The Neanderthals left Africa around 500,000 to 600,000 years ago. So they were already established in Eurasia. They lived on that continent and had lived there for many, many, many years. We don't have Neanderthal Y chromosomes in us, but we have other parts of their sequencing. And what did that? And so what's the conclusion there? Since there wasn't Y chromosomes from the Neanderthal in our a but we do have it. So it's more than likely it was a Neanderthal man who was intimate with a human, a Homo sapien, one of us. And that probably happened on more than occasion because we have about Europeans like us have about 2% of who we are is based on Neanderthal. And that did do some things for us. One of the things is that it gave us better autoimmune systems. We got some genes that taught us how to stave off more disease.
There it is.
And a few other things that, again, it's not entirely sure what everything was, but that's the main part. There's some other quick ones. Neanderthals and us share a gene called FOXP2. It's not an unusual gene, but it's one again, not at all. I mean, sometimes when it's in another animal, it's not used for anything. But for us, what it does is it gives us the ability to speak. Our whole language has its genetic. The Neanderthal had the same gene, and so now we're, I would say, almost 100% sure that they spoke. So when we first encountered them, again, I mean, we didn't speak the same language, but we were both speaking. So
No,
we,
thank you.
what happens is if you meet somebody, but sooner or later you get a few words that you understand, from each other. So that's more or less probably what happened. Let me turn it on. Okay. So that's pretty much it on the Neanderthal. I just want to cover just a couple of the misconceptions. I said that they spoke. My own take on it is that when we arrived on the scene, which was up, from migrations just weren't like they are today. It took a long time to go from place to place. You'd settle here, and then next year maybe you'd do another bit, and then another bit. We probably started interacting with them with Neanderthal about 75,000 years ago. My own take would be is they were a very small population. They were probably only about, in all of the European part, it was probably only around 3,000 to 5,000 people. Remember, they basically lived through the Ice Age, several of them probably, and it was a very harsh climate. Not enough food. You have to have enough food to be able to make yourself larger. So they suffered from that, having small numbers of people. And then because they were so small, there was a great deal of what we would call inbreeding, because they didn't have large groups. I mean, they did roam around and they could you know, a little bit. But when your total population is only 5,000, there's going to be a lot of, and then what that does is it degrades your ability to mutate and control mutations. So bad things don't get wiped away. Bad things get wiped away if you have a lot of people and somebody has something that's not right with your genes and they die from it. That eventually over time eliminates the bad stuff and you're only left with the good stuff. That's the sort of basic idea of evolution. So they were speaking people. They lived in caves primarily, although they also lived out in the open in the summer. They did all sorts of things that we do. They sang. At least we assume they did. They seem to have had flutes to make music with. They adorned themselves. You know, they have something nice to wear. They actually sailed on the Mediterranean. They actually were sailors. They made things like they were craftspeople. They also had medicine. They did the same thing that we do. Go out and collect herbs, and they knew how to, because they lived such a hard life. We know that they didn't live very long. I mean, 40 years was for them a long time, and it was partly because lack of food, but it was also largely these very large predators that like cave bears, wolves, and things like that, that would attack them. No, they were not. We are taller than they are, but not that much different. Neanderthal man would have stood at about 5'5". The women were about 5. So they weren't that much different. They didn't. If in fact, I've heard it said, and I've seen pictures of it. Believe me, if they were dressed up in modern clothes and you saw them, you'd say, well, they're kind of funny looking, but certainly you'd see them as human. You wouldn't, especially if you spoke to them and they answered you. I mean, there's no reason to think they weren't. Now that we know more about them and how they lived and the technology that they had, they were, for a long time, they were considered separate species. But there's so much overlap, they're not a separate species from us. They're merely a variant of who we are. So the new terminology for Neanderthals, it used to just be Homo neanderthalis, is now Homo sapien Neanderthalis. So what we are now is we used to just be Homo sapiens. Now we're Homo sapien sapien to show that we are the same. We're not a different species. We're the same. We interbred with them. How could we not? How could we be different? I mean, now I don't think that there were a lot of offspring from going back and forth with them, but certainly there was enough so that we all have some of this DNA in us. So, okay, so I guess that's about it. Those. Okay, gene disorders. There's a lot of them. A lot of the things that we consider disease are actually genetic problems. For instance, I think we all know about Down syndrome. That's not something that you come from your genes. It just, there's a certain overlap. Usually you just have 2 chromosomes that come together, have 23 and 23. But people who have Down syndrome end up with an extra chromosome, and that's what causes it, is that extra chromosome. Recently, my partner had developed breast cancer, and there's a gene for that. It's called BRCA1, BRCA2, and he took the test for it to see that it was present. Not so, I mean, we already knew he had breast cancer, but why would you take that test? Well, to inform the other members of your family. So he took the test, we verified that he had the gene. And so we went and told his nieces and the other women in the family, and also the men, because men can get it too, obviously. So the story with that particular test leads me to tell you this, which is, this was a legal case that happened in 2009. Again, things aren't the way they are today. You just couldn't do a swab and go in and have it tested. So a company, I think it was in out west, called Myriad Genetic. Hey, they knew how to do that. They had patented it, as a matter of fact. And so for the test, like when Ken had his test, it was just done at the hospital, it wasn't any big deal. They were charging tens of thousands of dollars to women to provide them with the test to find out whether or not they were carrying the gene. So the ACLU got into this because question is whether or not that was right. Not only was it wrong to be greedy, but also do they have the right to say that gene is something that they discovered, which is what they claimed. So that, of course, we all know how slow justice grinds in this country. In June, this is a big date for genetics, June 13th, 2020, it's only 10 years ago, SCOTUS, Supreme Court said that, no, you can't patent a gene. It's something that occurs in nature. You didn't make anything. You just figured out what it was. And I just want to read you what your Justice Sotomayor said. She says, cutting off a slice of liver doesn't make that that piece patentable. But you take a gene and snip off a piece. That is. So what's the difference? There's no, you can slice up a piece of liver and say that, if you can do that, then how come you can't? So I thought that so that what that did is that you cannot patent genes, in other words, it's not patent. The other thing that they did, and I didn't cover too much because I didn't really think that I really wanted to push too much of that envelope, is that when I mentioned that you can download your genome onto a drive, and there is a piece of software that you can get for free that you can crank it through and find out things about yourself. A doctor cannot take your genetic material and use it to provide a diagnosis, except unless you give them permission. So there's more strict rules about who can use your genes to find out things about you. Okay. Trying not to talk a lot, but I know I'm a big talker. So that's the next thing I want to go into is 23andMe. I went through it today. Within the last 6 months or so, the database was hacked. So when I went in to sign in today, I had to do a new password. I had to do a verification code thing. So that was I read quite a number of people writing about that hacking and being a little bit over the top. I said to my sister this afternoon, the hackers might have gotten into and seen your relatives and maybe use that as a scam, or contact your relatives and say, I'm so-and-so or your cousin or something like this. But that would be about the extent of it, because if they wanted to get your DNA, all they'd have to do is get access to your house and sweep your floor a little bit.
Yeah.
Because we're shedding skin all the time,
Yes.
and the dirt, most of the dirt that's in our house is our flaked off skin. Believe it or not, all mixed in with the dust and everything else, but that's what it is. So that I don't think that's something that anyone needs to worry about. Okay, I think the hackers just did it because they could do it. The two databases that I've used, my brother did Ancestry, but I just did 23andMe, and then I did another one which is partnered with the National Geographic Society, which is a more scientific one. 23andMe tends to be a little bit, it's not bad. It's just that it doesn't have it's more popular. It's easier to work with. The other one you have to really crunch around for some things yourself. Both of those, and you can grab your genome from both of them. They're both downloadable. You just have to find the button. Okay, one of the things that 23andMe does, because they were started up as basically health. Like I said, here's an example. There are more than 10,000 single gene what's that word? Disorders. So that's partly what they were doing, is that there's a large, it's only about 2% of the population who are affected by these genetic disorders, but still, that's a significant amount. So that's where they got started. One of the things that they do is they use that to, and this I thought was kind of fun. They're called traits. In other words, things that we can predict from seeing your genes about you, maybe your physical appearance, other things. And I just wrote down a couple of them just so that you get an idea. One is called the alcohol flush reaction.
What's that?
Well, if you're drinking alcohol, you get a red face.
Oh, yeah, I do.
So, okay, another one, and I just took down a few, just some, so she have an idea. I think there's 40 of them. Caffeine consumption. Well, this is for me because that's all I can see. It's mine. I'm more likely than most people to drink a lot of caffeine. I checked this one with my sister. I asked her, I said, well, do you like cilantro? She says, no, I can't stand it. I said, that's right, neither can I, because it's in our genes. It's a gene for it. Yes, it's one of those genes. So this is the kind of, it's kind of fun stuff. The most popular one that you'll hear all the time is earwax. It's basically two kinds of earwax, either you're wet or you're dry. That people have known that for a long time. This one sort of is interesting. I mean, it tells you how much they can find just by sequencing your genes. Eye color. It told me that my eyes are hazel. My eyes are hazel. They are, I know. Oh, I'm somebody who has an intense fear of heights. Again, for my genes. Yeah, some people don't. Some people do. Okay, and I have dark hair, or at least I did. And my wake up time is around 6:45. Who knew? So that's one of the things 23andMe does. Like I said, I think I enjoy them. And of course, the other thing that they're doing now, just in the last month or so, is because they're a health thing and they're selling that part of their database more, is they're expanding what the health information that they're going to provide to you from your DNA. So they've got created another tier. So if you want to do even more than what they allow you to do now, you can do that. The other database is Family Tree. Again, I said that's sort of in conjunction with National Geographic. What National Geographic did some years ago when they were creating this database is, instead of having people send in the samples and then categorize them, what they did is they sent teams of people out across the entire world. So they would go to places where people probably would not send in the sample of saliva to get more DNA. So they send people to New Guinea, or make sure they get a lot of Australian outback people, or maybe down into the sub-Sahara. So we have a representation of the entire world. More different pieces you have, the more accurate it's going to be. So that's what they did. And that's one of the reasons I went with them, because even though it's kind of kludgy, it's certainly not easy to find relatives in that one. But the information is good. The other thing is if you're doing genealogy, as I did with mine, and I said this in the last talk, Betsy, is that my mother's half Swedish, and Swedes are a difficult place to do genealogy over in the old country, because in the 19th century, the king wanted to modernize Sweden, and that was his. He looked at the other European countries and he said, "We've got to get us back out of the old ways and into the new ways." And one of the old ways that he wanted to get rid of, this is a cultural thing, is the same as we all know. Well, I think we all know that in Iceland you don't have a surname. If your name is Inger, you might be Inger Peter's son or Peter's daughter, or maybe you have a son and you're Carl Eric's son. So that it's just who your parents named their first names. The king in England and in Sweden said, No, we're not doing that anymore. We're going to have surnames, just like the rest of the Europeans do. So people didn't have, most people, some of the aristocracy actually had surnames, but the common people did not. So what he did is he sent out an edict, and it was basically one from column B and one from column A. So my family's name is Lindbergh. So they chose Lynn, which is a kind of tree, like a linden tree, and Berg, which means a mountain. So people did that all through the country, but it doesn't. But just because you like the name doesn't mean that you're related to those people. So the Lindbergh is a very common Swedish name. But how do you find out which Lindberghs are yours when everybody just went and picked a name out a few hundred years ago? So what the trick that I found with the second database, this family tree DNA, is that it provides maps. So when you usually, most of them will tell you, you know, this is where Sweden is, but this particular one shows you where your cousins live in Sweden. So I looked at the map and got down to a kind of fine level, and I could see that most of my cousins lived in the northern provinces, not in the southern provinces. And just like it is here in Canada, most people in Sweden live in the southernmost part of the continent, the country, and not the northernmost, where it's much more cold. So that gave me a hint. I went, well, so now I can eliminate the Lindberghs who live in the south. I can only look at Lindberghs who live up that way. And so that's what I did. I just kept working with that and working with church records. And one of my friends from Hubbardston was good enough to, when I couldn't read their baptismal records. They don't have, Sweden is similar to other, not Catholic countries because they're Lutheran, but a lot of records were kept by the church, birth records and things like that. So that's what it is in Sweden for the 19th century. So I located some that matched me, and I had asked to read them to me and find out what they did. And I knew from others of my cousins when they came over to New York, and then they went out to Minnesota and then finally Alberta. I located them, and they were in a little town called Luleå, which is up at the up where Sweden and Finland come together. Right up, it's only a few miles from Lapland, very close to the Arctic Circle. So that's where they came from. I found that out. And that was just because I saw the maps and I was able to use that clue from the maps to go to another, which is also why I have a tiny bit of Finnish in this. Because they were so close together. The town Luleå now is has a big name in the computing world because it's so far north. Computers take a lot of cooling off because they're running their engines and such all the time. If you have probably not so much these guys, but if you have a regular desktop like we used to have, that you can hear the fan going to cool them off. So what I don't think it was Netflix. I think it's MSN, like Microsoft, because it's so cool there. They staged all their big servers that serves the rest of Europe are up there in Luleå, which is just a small little town of about maybe 20,000 people. So there you go. So questions. I'll try if you ask me a question.
Well, I remember the last time you spoke, you said that the Finnish genes, or I don't know if I'm going to use the right terminology, but the Finnish chromosomes were unique. I can't remember the rest of your talk about that, but the fact that Sweden owned Finland for 800 years, the records are a lot in Swedish as well. So do you happen to remember what that was that you had said about the?
Sure. Well, Finnish people, as opposed to a lot of other people, are what's called endogamic. Endogamic, gam meaning wife. So most Finnish people marry and have children with other Finnish people. So the genome for the entire country is pretty tight. It'd be like, think about it. I mean, it's not a village, and because of where they are in Europe, they're in an isolated area.
Yeah.
There weren't Spanish people moving up into Finland and marrying Finnish women.
Right.
So the genome for the entire ethnic group is pretty homogeneous. So that so they've been able to find, if you have a little Finnish in them, they pretty much know what Finnish genes look like, or what they call SNPs of it. They know pretty much what it looks like. So it's one of the ones that you can. I'll give you an example. All right, think of Rome. Think of Italy. How many waves of different migrations went through Italy?
Oh, yeah.
I mean, there were Germans there were Visigoths, there were people from Sahara, there were Greeks, they were Spain, they were all over the place because of that civilization.
Right.
Finland was very isolated and for lots and lots and lots of time. If Finns themselves, as an ethnic group, come from Central Asia, and they moved up into Finland about, I think it's around the year 1000, or maybe a little bit earlier than that. I have a nice book at home that I think it was a Hungarian photographer went out and he found the other ethnic groups that are in Central Asia, which is a very large group, and showed photographs of them, and you can tell that I mean, I think a lot of people think of Finnish people as being fair haired, but they're not.
They're not.
They're not. They're dark haired people. If you're blondish, then it's probably the Swedish part that's coming through.
Well, that's an interesting thought. Yeah.
Because I mean, obviously, if you have a control over a country for that long, I mean,
800.
yeah. that's sure. I mean, I've seen. There's one dance instructor who he's an older. I think he's passed away now. He teaches the tango. Finns love tango.
Oh, they do.
And this was a YouTube of him teaching people how to do the tango. And he spoke Finnish, but he had a Swedish last name. You could look at him and go, yes, he's Swedish. He's got the Finnish, I hate to say it, the head.
Yeah. Yes. How about the third program? I'm thinking of the one that Ancestry.com does for attesting DNA.
My brother did that one, and I'm not familiar with it, so I really can't speak to it. I assume that it's much more geared towards genealogy than either 23andMe or familytree.com. The thing I think about Ancestry, and I could see why you might want to go that way, is that you have access to all those documents at the same place. So you wouldn't have to like one-stop shopping. You can go in there and find a genetic background and then pursue it a little bit further. The Family Tree and Me also does another location thing in that it will tell you, and this is a new feature since I first started with them. It'll tell you the likelihood of where your folks came from. So the thing that I did at first was doing it on my own, looking to see where my cousins were, and then figuring that out. But they added that function to the database now, so they'll tell you where your folks may be from, or people with your particular genes that probably came from this. Do you remember those little Swedish horses?
Yeah.
Wooden Swedish horses?
Yeah.
That's from Dalma, and that's where most of my family comes from. So I think when I see my little horse, I think, it's one of my uncles or my father's car. And that's Dalma is the place. It's sort of not way up. So it's sort of like when we have our camps in different places. That the Swedes do the same thing. They have camps up in the Dalma means dell. In English would be dell. D-E-L-L. So
Interesting.
So that's why they sell the horses.
So you had your DNA done,
Yes.
and so do you have to resubmit anything to get any more information and stuff, or do they just keep you in the database and do you have access to that?
That's a good question, Bob. Yeah. Since most of what we have is all the same, there's only a very, very small part that's different. The databases don't show you the depth that you might want. In other words, they're not going to tell you, they give probabilities. 23andMe will notify me probably every 6 weeks and say, you have new relatives. Well, yeah, they're new relatives, but they're like fourth, fifth, sixth cousins.
Yeah.
I mean, they're so far away. I know that people have also asked me about, all right, I was talking to my sister about things today. And I said to her, well, this whole hacking business where they were worried about someone, masquerading as your cousins. And I said, I've been in those databases for almost 10 years. And I found the only cousins that ever reached out to me or that I ever had connection with, once I wrote to them, were from the same family, the Smith family, and they were from here in Westminster.
Oh, my gosh.
And but those are the only cousins that I've ever, if I've ever written to them or anything that they ever wrote back to me. My aunt, who's my mother's sister, who's still with us, she was after me for a while to see if I couldn't find some of the Watson family, who lived in Pittsburgh. And so here one day I look in and there's Ronnie Watson. And I went, well, what are you doing there, Ronnie? So I wrote to him. Now, he was my mother's first cousin. So I wrote to him and I said, oh, I remember when you lived over on what he was known. I said, remember him? It's just behind where my great grandparents, his grandparents lived on Highland Street. And I went, detailed all of these things. And I said, oh, and I remember this sister, and I remember your brother, John. And wrote this whole big thing because I wanted him to know that I was legitimate. And I said, and Evie, that's my aunt, said, Evie has been looking for you and she'd love to have contact with you. Never heard from you again. So some families, so that's the rule of thumb for me has been anytime I did have a young lady write to me when I first started, and her father had been adopted. She knew that he was from down Maine, but he didn't know who his family was at all because he had been adopted. And she saw that we had a significant amount of relation to each other. But I wrote back to her and I said, this was when I was early on, because the database wasn't populated with enough of my cousins so that I could figure out, you can triangulate. If you see this, if Ronnie shows up in hers and I show up in hers and somebody else shows up, then I know it's the Watson family that she's related to. But it took a while for me to get enough cousins in there so that I could do that and see which way she went. So I've been writing to her for the last year because I wanted to tell her, well, I know how we're related now to the Watson family. Maybe I can help you out finding how your dad, who's my age, how your dad, who he's related to. So it's just like everything else. It's like email and stuff. Did I get enough of that to get you to understand, to get that? Yeah, what I did get today when I logged into 23andMe was why don't you upgrade? Well, as soon as I saw upgrade, I went, okay, so what this is a money bag. Money bag. So what they're going to do is they're going to give me more features. It was just going to be for analyzing what I already, and I don't need to know anything more about my family at this point because I've been doing it since I was 16. So I have pages and pages. My Smith cousins, who I ran into most recently, that was the biggest part of my family that I did not know where they came from. I mean, I knew they came from New York. I didn't know where they came from in the old country. And one of my cousins that I ran into, he and his wife had done quite a bit of work and got the family tree all the way back to when they first came over. And they're from Germany.
And this is the Smith family? I didn't think of a Smith as being from Germany or anywhere.
Schmidt.
Oh, Schmidt.
Yeah, they changed it, they anglicized it. Yeah,
They
Schmidt.
anglicized it to Smith.
Yeah.
Oh.
And they had that story. That's why I'd like to do not so much the genealogy. The names are fine, but I like to know this story.
Yeah.
How did they come to be here? And what it was is that this happened in the mid 18th century, so around 1740 or so. In Europe, there was a tremendous cold spell. So cold that the birds were literally falling out of the sky. And they lived over by the Rhine River, you know, sort of, it's in between. It's near what Hamburg and Mentz are now. So they were farmers, and it was, you know, the things were rough. And so a rumor was spreading around, just like in today's world, rumors spreading around. And it was rumored that if you could get to England, they take care of you. The English would take care of it. So hundreds of thousands of these Germans flooded England, just again, like the migrations that we see today, flooded them. And the English, they had nothing, they weren't interested in helping anybody out. And they didn't know these people from Adam. So what did they do? They had New York by this time. They had New York from the Dutch. So what they did, send them over, and they were all sent over to New York as indentured servants. And the indentures, that was because that was their paying their fare to go over there. So that's why there's a lot of Knickerbocker, they call it.
Oh, yeah.
That there were hundreds of thousands of these people who came into New York.
Are they the ones who eventually settled Pennsylvania?
No, those are the Amish. Those are the Mennonites. They're from a
But
different.
there were Germans in Pennsylvania. as
Yeah,
well.
they're German people. They are
Oh.
German people, but that was a different, that
A
happened
different way.
later.
Oh,
That
okay.
happened later. This was the first one.
Oh,
There's a poem by, let me see if I get it right. I think it's, no, I'm not gonna, I think it's Longfellow. Maybe I'm wrong on that, but it's called The Palatine. And it's about a shipload of these people, because that's where they came from. The Palatine was the name of Germany where they came from. This is a ship that came over, as in it got close to our coastline, like around Rhode Island and all. A storm came up, and this was the story that was told regularly in the 19th century. And so the people of Block Island, which were right there, had built a big bonfire, and they got the ship to come in, and it shipwrecked them, and they stole all of the goods that they were bringing over.
Mm.
And so the story is that after what that awful thing that the Block Island people did, that a ghost ship would be seen down on that end of the island in poor weather. So that was the basis of it, because it's a sort of folk story.
yeah.
And that became the basis of Longfellow's poem, The Palatine is called.
Wow. And Nick has a question.
Oh, sure.
I was trying to make a connection with the Dutch settlement of New York and western Long Island,
Mhm.
Nassau County and the boroughs. Those Dutch came over in 1600.
Yes,
It's not part of.
No. I'll tell you the names of the people the famous German people that you would know who came over in this first big wave: Eisenhower, Roosevelt, Platts, New Platts. Those are the towns that they settled in. But most of them were indentured people, so they were just, you know, they just like a lot of it happened here in New England too. And there was a lot of indentured servants brought over. They wanted to come over, and that's the way they came over. And they'd work, I don't know, depends on the term of it, but usually 10 years or more. And of course, they all had the worst jobs.
Wait, no, Roosevelt, are you talking about the Germans or the ones that came to New Amsterdam?
My understanding is that the Roosevelt family was descended from the Germans that had come over.
Okay, because I have Roosevelts in life,
Mhm.
and they came to New Amsterdam back in
Oh,
the
okay.
1650s.
Oh,
So yeah,
But of course, it was the Dutch who gave Yankees their name.
yeah.
They're the people who called us